Good morning friends. Now today we are starting chapter 10 problem. First one. In a Young's double slit experiment, the slits are separated by 0.28 millimeter and the screen is placed at 1.4 meter away. The distance between the central bright fringe and the fourth bright fringe is measured to be 1.2 centimeter. Determine the wavelength of the light used in the experiment. Now the given data lambda is equal to question mark, d is equal to we are considering 0.28 millimeter, or that can be also written in 0.28 into 10 raised to minus 3 meter. D is equal to 1.4 meter. X is equal to 1.2 centimeter. Therefore n is equal to 4, that is the fourth bright fringe. Now according to the formula we are considering xl is equal to delta x into d by small d. Now in the case of the conjunctive interference, we are considering delta x is equal to n into lambda. Just we are putting the value of the delta x. Now xn is equal to n into lambda into d by small d. Therefore lambda is equal to d into xn by n into capital D. Therefore we know that n is equal to 4 and lambda means wavelength of the light used. We have to find the value of the lambda. Now according to the formula of the lambda, now lambda is equal to we are considering d into xn by n into d. Now let's put the value 1.2 into 10 raised to minus 2 into 0.28 into 10 raised to minus 3 divided by 4 into 1.4. The calculation part of this we are getting answer as 6 into 10 raised to minus 7 meter, or that can be also converted into 10 raised to minus 9, that is Newton meter. Sorry, nanometer. Therefore lambda is equal to we are getting as 600 nanometer. This is the in the question we have to find the wavelength of the light used. Therefore the wavelength of the light used in the experiment lambda is equal to 600 nanometer. Now the next question. The refractive index of a glass is 1.5. What is the speed of the light in a glass? The speed of the light in vacuum is 3 into 10 raised to meter per second. Here we have to find the speed of the light in a glass. Now first we have to write the given term. According to this, the refractive index of a glass means theta is equal to 1.5. Next we have to find the speed of the light in a glass. V is equal to question mark. Next they have given that the speed of the light in vacuum is 3 into 10 raised to 8, that is small c into 10 raised to 8 meter per second. Now here V is equal to question mark. Now by using this we have to find the value of the V, that is the speed of the light. Therefore V is equal to c by n. C by n. Put the value of the c and n. 3 into 10 raised to 8 by 1.5. Therefore, calculation part v is equal to we are getting the answer as 2 into 10 raised to 8 meter per second, or 2 into 10 raised to 8 meter per second. Therefore, from the question we have to find what? The speed of the light in a glass. Therefore, the speed of the light in a glass V is equal to 2 into 10 raised to 8 meter per second. Now next question, third one. The light of the wavelength of 5000 angstrom falls on a plane reflecting surface. What are the wavelength and the frequency of the reflected light? For what angle of the incidence is the reflected ray normal to the incident ray? Here we have to find that for what angle of the incident is the reflected ray which is normal to the incident ray. Now according to this, first we have to write the given term. Here just we are writing lambda means wavelength is equal to 5000 angstrom. They have given the value of the lambda or the wavelength is equal to 5000 angstrom, or this can be also written in the form of 10 raised to minus 10 meter, the value of the lambda. Now next we are considering c is equal to 3 into 10 raised to 8 meter. The speed of the light in a vacuum, c is equal to 3 into 10 raised to 8 meter. Now according to this, the frequency of the incident light, V is equal to c by lambda. Now put the value of c and lambda. C is equal to 3 into 10 raised to 8 divided by 5000 into 10 raised to minus 10. Now the calculation part, we are getting the answer V is equal to 6 into 10 raised to 14 Hertz. 6 into 10 raised to 14 Hertz. Or here 5000 is there, this can be also written in the form of 3 into 10 raised to 8 divided by 5 into 10 raised to 3 into 10 raised to minus 10. Now 3 divided by 5 into 10 raised to 8 minus 3 plus 10. Now here we are getting total answer is 15. Convert that answer, we are getting 6 into 10 raised to 14 Hertz, the value of the V. Now next, from the data we can write that angle of incidence and the angle of the reflection. Angle of incidence plus angle of the refraction is equal to 90 degree. According to the question, just we are considering the angle of incidence plus angle of the reflection is equal to 90 degree. Now next we can tell that the angle between the incident ray and the reflected ray is also 90 degree. From the law of the reflection, the angle of incidence is equal to angle of reflection. The law of incidence we can write angle of incidence is equal to angle of refraction. Now by this we can write that 2 times of the angle of incidence is equal to 90 degree. 2 times of the angle of incidence is equal to 90 degree. Therefore, the angle of incidence, just we have to find the value of angle of incidence. The angle of incidence equal to 90 degree by 2. Cancel it out, we are getting the answer as 45 degree. Therefore, the angle of incidence is equal to 45 degree. Now, next question. The interference is produced by the waves from the two sources of the intensity I and 9I. Calculate the interference pattern at the point where the phase difference is. First they have given that pi by 2. Second one, the pi. Means one is 90 degree, other one is 180 degree. Now in this question, we have to find the interference pattern at the point. Just we have to find the interference pattern at the points at 90 degree and other one is 180 degree. Now according to this, first we are considering I1. I1 is equal to I. Given the value. Next, second one, I2 is equal to 9I. First one, I1 is equal to I, I2 is equal to 9I. Therefore, IR is equal to question mark. Next, the formula for the IR. Here we have to calculate the value of the IR. Therefore, the formula of IR is equal to I1 plus I2. I1 plus I2 into 2 root of I1 I2 cos phi. Cos phi. Therefore, or this can be also written in the form of pi is equal to, first we have to consider the value pi is equal to, we are considering pi by 2, that is equal to 90 degree. Now put the value of pi. Now we are getting the answer as I plus 9i into 2 of I1 I2 I into 9i into cos 90 degree cos 90 degree. Therefore, when we are calculating, we are getting the total answer IR is equal to answer is 10i. The value of the cos 90 we are considering 1, and here I plus 9i and root of I into 9i. Calculation part, calculate the value of the IR is equal to 10i. In the same way, we have to calculate for the second value. Therefore, psi is equal to pi degree pi, or it is equal to 180 degree. Now put the values. IR is equal to I1 plus 9i root of 2 into, now next IR is equal to I plus 9i into 2 into root of I into 9i into cos 180 degree. Now the calculation part of IR, we are getting the answer as 4i. Total value of the IR is equal to 4i. Therefore, from the question we have to calculate the interference pattern at the point. Therefore, first interference pattern at the 90 degree, we are getting the answer as 10i, and second one we are finding at 180 degree, IR is equal to 4i. Now next question. The rays from the two coherent light source of lambda is 0.5 micrometer and the path difference of 0.5 millimeter at a certain point in the space. Will the interference be the constructive or destructive at this point? Just here we have to tell that either the point or the interference is at the constructive or destructive at the point we have to study. Now in this case, first we are writing that path difference is equal to n lambda. Given that path difference equal to n into lambda. Now next we have to consider here n is equal to, the value of n is equal to 0, 1, 2, 3, so on up to the last term. According to the path difference, we have taken the formula as the n into lambda, where n is equal to 0, 1, 2, 3, so on up to the last term. This is for the constructive interference. Here we are considering for the constructive interference. Now we can tell that 0.5 into 10 raised to minus 3 is the path difference. 0.5 into 10 raised to minus 3 meter we have taken, and is equal to, we can write here n into lambda. The value of the lambda is 0.5 micrometer. Means we are considering 0.5 into 10 raised to minus 6 meter. From this we have to calculate the value of the small n. Therefore n is equal to, we are getting the answer as n is equal to, we are getting the answer as 1000. Therefore n is equal to 1000. It is an integer. Therefore the interference is at the constructive point. The interference is at the constructive point. And it is not a destructive point.